In this example, we're asked to find the inverse of a given function here. We're told in the problem that the function is 1-to-1, so we don't need to verify whether this function has an inverse. Since we're told that it's 1-to-1, then we know that it does have an inverse function. So to find that inverse, the first thing we do is we swap the input and the output variables, which typically means swap x and y. So these x's will turn to y's. Remember that the h of x here, this is your output, so also known as y in most of our problems. So this will change to x when we swap x and y. And so I'm going to go ahead and write this as x equals 2y minus 3 over y plus 1. Okay, so we've swapped x and y. Now the goal is to isolate y. So the first thing we could do, this is always a decent idea when you have fractions in a problem, is to clear the denominators by multiplying both sides of the equation by the least common denominator, which since we only have the one denominator here, y plus 1, then that's our least common denominator. So I'm going to multiply it on both sides here. So on the right side, the y plus 1s will just cancel, which that's by design. That's the whole goal here was to clear the denominator there on the right side. On the left side, I'm going to multiply this out. So I'm going to distribute the x here to both parts of this expression so that the left side becomes xy plus 1 times x, so x. Now again, the goal is to isolate the y's here. So in general, when you're trying to solve for a variable that appears in the equation more than once, this is what you should do. First, collect all the terms that have that desired variable on one side. So in this case, we're trying to solve for y, so we should collect the y's on one side. So to do that, and let me mention this too, and move all the terms that do not have a y to the other side. So on this step, we're kind of sorting the equation. You can think of it kind of like the way that you sort laundry. So I'm going to move the y terms to the left side, and there's nothing special about that. You're going to get an equivalent solution if you move the y's to the right side. And I'll go ahead and write this step out. So xy minus 2y, I still got that plus x there. Oops, I'm sorry for what that looks like. 2y minus 2y, so that's gone, equals -3. This is a y right here. Anything that doesn't have a y, send it to the other side. So I'm going to subtract x from both sides. So I now have xy minus 2y equals, these are gone, -3 minus x. And let me see if I can, here we go, bump that up a little bit. Okay, so collect the y terms on one side, put all the other terms on the other side, and then factor out the y. So if I'm continuing in the steps off to the right in black here, that would be the next. Whatever variable you're trying to solve for, factor that out now, once you've got the equation sorted. So over here, if I factor out y, I have x minus 2. Now you could factor out a -1 over here on the right side, but I'll just leave it alone. And then, so one last step, divide by this other factor to get y by itself. So divide by x minus 2 on both sides. And I guess I'll list that as my third step here. Divide by any remaining factors to get the desired variable by itself. Okay, once you've got it solved for y, then that's your inverse function. So I could now write, oops, I was going to call it f. The name of this function was h. So h inverse is equal to -3 minus x over x minus 2. And I'll box that up. Although, if you like to present your solutions as maybe cleanly as you can, There's a couple things we could do to clean this up. So we could factor a negative out of the numerator there, and we'd have positive 3 and positive x. And then you could, for something like this, multiply top and bottom by negative 1. So in the numerator, negative 1 times the negative out front, those multiply to give you positive 1. So it's just 3 plus x now in the numerator. In the denominator, if you distribute, we now have positive 2 and negative x. So this looks a little prettier, but it's fine if you leave. It's an equivalent expression, what we have up here. The form that you get kind of depends on if you collected your y's on the right side or the left side. So your solution might not look exactly like your friend's if you're doing homework with a classmate, but they could very well both be correct.